All right, we're going to do one big example, and it's really going to summarize all these things we've been doing throughout this chapter. We're going to calculate means, standard deviation, z-score. We're going to look at the quartiles. We're going to figure out our fences and determine if we have any outliers, all with one big example. So if you do not have this data in your calculator yet, you need to pause the video, and then you need to put it in. So you're going to go Stat, Edit, and then you want to make sure that you get all these data points entered. So go ahead and pause and do that, and then come back and join me. So this is the data for hemoglobin levels for 20 randomly selected cats. I swear my examples are so random. If you were wondering, gosh, when is she going to do an example about hemoglobin levels of cats? Well, today's your lucky day. So we've got all of these levels. I don't know what's considered normal. I just know that these are all the different levels for 20 different cats. It goes from 5.7 up to 13.4. And the first thing we're going to do is we're going to calculate the mean, and we're going to calculate the standard deviation. And we want to make sure we use the right notation. So we have to decide, is this a population or is this a sample? And because it says 20 randomly selected, this is a sample. I mean, you know there's more than 20 cats in the world, right? So this is a sample. So the mean is going to be X bar, and the standard deviation is going to be S, because that's a notation that we use for samples. All right, so if you've got your data in there, I'm going to quit out of this screen. I'm going to go to Stat, Calculate, 1var stats. I want my calculator to look at list 1, so you can type L1. Again, if you have the older calculator, you don't have to type anything. It will automatically look at list 1. Go to Calculate, and now I've got this whole screen of output. So we know that the mean is up here at the top. It's 10.08, and I'm not even going to bother rounding. And then as far as the standard deviation, remember you have to decide between S and sigma, and since this is a sample, we want to look at S. Let's go 2 decimals here because the mean was 2 decimals. So I'm going to call that 1.89 if I round it, 1.89. And the units here would be whatever the units are for hemoglobin, which quite honestly, I don't know what those units are. All right, so we have the mean and the standard deviation. Next question. A cat named Daisy had a hemoglobin level of 7.8. That's her individual hemoglobin level. Calculate her z-score and interpret. Okay, so we have her data point is 7.8. And we know the mean and the standard deviation. I'm going to rewrite them. The mean and the standard deviation from before, because this is how we set it up earlier, right? Okay, now to calculate the z-score, you go data point minus the mean over the standard deviation. Let's see what this is going to give us. Now, you'll notice her hemoglobin level was lower than the average, so this should turn out to be a negative number. So I have to quit to get out of this screen. So second quit, 7.8 minus 10.08 over the standard deviation. And I get roughly negative 1.21. Which is negative, which we knew was going to happen because I just said her hemoglobin level was below the mean. So there's her z-score. But it says interpret. So what does that actually indicate? What does negative 1.21 as a z-score tell you? It means that Daisy's hemoglobin level is 1.21 standard deviations below the mean. And this is what I'm looking for when y'all write sentences like this. I want you to tell me the number. I want you to mention standard deviations, and then you tell me if it's above or below. You'll notice I did not put a negative here, because when we speak in words or when we write in words, it's a little different than how we write numbers. When I said below, that was the negative. If I said negative 1.21 standard deviations below, that's like having a double negative in my sentence. So if this is positive, you'll say above the mean. If it's negative, you can say below the mean. But this tells you how far below the mean. So again, if we had a picture and if we assumed that the hemoglobin levels were bell-shaped, then let's say -1 is here, -2 is here. Miss Daisy, -1.21 would fall about right there. So it tells you how many standard deviations below the mean a data point fell. So that's where she is in line with all of the other cats. Okay? All right, so mean, standard deviation, and z-score. That's a nice review. All right, now what we're going to do is we're going to do the IQR and the fences, and this is the stuff we haven't calculated yet. So we're going to need to go back in our calculator to OneVar Stats. We need to rerun OneVar Stats so we can get it on the screen. And we need to scroll down. We know we had 20 cats. We can see the minimum, we can see the maximum, and here's the quartiles. Now they're not going to call it Q2, they're going to call it median, but you need to just know that's Q2. So Q1 is 9.15. Q3 is 11.1. And from that, we can figure out the IQR, okay? So the IQR is Q3 minus Q1. So it's going to be 11.1 minus 9.15. So we're going to subtract that. And again, I'm going to lose this screen. 1.95. That's how wide the spread is, which is actually not very wide. 1.95 is pretty small spread for that middle 50%. All right, now what we're going to do is we're going to create the lower fence, and we're going to use the formulas that they gave us. Again, you don't have to memorize formulas. They're going to be on your formula chart. So I'm going to take Q1, which is 9.15, and I'm going to subtract 1.5 times my IQR. So I'm just plugging into my formula. Q1 minus 1.5 times my IQR. I can go to my calculator. I'm going to type it with the parentheses and everything. 9.15 minus 1.5 times the IQR. And that gives us 6.225. That's my lower fence. I'm going to draw a picture of this in a second, and I think it'll help clear things up. Now we're going to do the upper fence. So you start with Q3, which is 11.1, and you add the same amount, 1.5 times the IQR. So 11.1 plus 1.5 times the IQR, we get 14.025. So what the heck does all of this mean? It's just like a bunch of numbers thrown on the page, right? So let's try to get a picture of what's happening, okay? Let's say we have a number line here, okay? And this may not be terribly accurate, but let's see, if I go, let's say this is 0. I'm going to count by 2s. All right, if we want to look at the Q1 and the Q3, 9.15, let's see, 9 would be here. So 9.15 is just right about there. That's Q1. And Q3 is 11.1. So there's 11.1, so just right in there. That right there is your middle 50%. Q1, Q2, Q3 is all in there. That's your middle 50%. It's a distance of 1.95, okay? Now, we got a lower fence of 6.225. So we got a lower fence right about here. If you take 1.5 of those and subtract them from this point, you end up with that as your lower fence. And then if you take 1.5 of these and add them on, you end up with right at around 14. So the distance from this dot Q3 up to my orange fence should be the same as the distance from this purple dot at 9 down to the lower fence. Those should be similar. So what you have is, you've got your fences. If you have any data points that are smaller than 6.225 or bigger than 14.025, you know you have an outlier. So let me label these. Any data points that fall outside of that fence would be considered outliers. So now I want to know, do we have any outliers? Well, I don't know. Let's look at the data set. Let's see if I can get it all on here. There's our data set. We're looking for numbers smaller than 6.225. Let's start there. Anything smaller than 6.225. That's an outlier. 5.7 is an outlier. Do we have anything bigger than 14.025? No, because our maximum was 13.4. Here's what I think is interesting. When I look at this data set, 5.7 doesn't stand out like an outlier. Like, I wouldn't have guessed that that was an outlier, but it actually turns out that it is. When I keep talking about, of course, it's my oversimplified example of we have a bunch of 25-year-olds in the room and then a 90-year-old walks in. Okay, that's obviously an outlier. Like, I don't think that's surprising to anybody. But this one doesn't seem like an outlier. That's why when you're doing statistics, you can't base it on your feelings. You need to calculate these numbers so that you'll know definitively. So are there outliers? Yes. List them. 5.7. That was the only one that we had that was an outlier, because 5.7 would be over here outside of our fences. Okay, so that's how you calculate fences, and that's how you figure out if you have any outliers. All right, the last thing we want to talk about is which statistics should I use for my data set? Should I use mean or median? Should I use standard deviation or IQR? So now is time where you already know this with mean and median. We've already talked about that, but now we got to talk about measures of spread or dispersion. So you should know that measures of center and measures of dispersion come in sort of married pairs. They're always side by side. So we talked about resistance also. Symmetric data does not have a bunch of extreme values. Skewed data does. It'll have extreme low values or high values, which is what's causing the skew. If you have skewed data, you need to be using things that are resistant. You need to be using statistics or parameters that are resistant to those highs and lows. So we talked about before, if your data is skewed, you really should be using the median if you're discussing the center. But if your data is all nice and pretty and symmetric and everybody gets along, then you should be using the mean, because the mean does not like extreme values. It's not resistant. Okay, so you want to use the resistant ones here with skewed data. So then think about standard deviation and IQR. Which one is resistant and which one is not? Which one of these acts like a mean? In fact, you can answer it by saying which one of these actually has the mean in its formula, and that would be the standard deviation. The standard deviation is a measure of how things vary from the average on average, and so that should be paired with the mean, and you should only be using it if your data is symmetric. IQR is made of quartiles, and the median is Q2, so this should be paired with median. So the way these are calculated, they go hand in hand. So mean and standard deviation are a pair. They always go together. If you calculate mean, you should be calculating standard deviation. Median and IQR are a married pair. If you do one, you should be calculating the other. If your data is weird and skewed, use median and IQR. If your data is nice and symmetric, use the mean and the standard deviation. And you got to know this table.